Okay, hello everybody. Good evening, all of you guys. Am I audible properly? So I hope that I am audible to you guys. Please let me know that you are able to hear me out. Please let me know that I am audible to you or not. Visibility is also clear or not? Please let me know. Okay, great. Okay. So once again, guys, welcome back to our classical thermodynamics lecture number 2. And good evening, all of you. Very good evening, all of you. I hope that you guys watched our previous lecture, that is our lecture number 1, in which we basically discussed the basic things about the thermodynamics, that what is the weightage of the classical thermodynamics in the GATE examination, and what is the type of this subject, what type of questions we can expect in the GATE, and also that some basic informations we already discussed, right? Like what is the thermodynamics, okay, what is basically this subject, what is the types of the system, what is the surrounding, what is the system, what is the universe, and what are the different types of the system, in which we have discussed the 3 types of the system. I hope that you remember that information, okay? That our first system is my closed system, after that open system, and third is my isolated system, right? So let's go through very quick whatever we discussed tomorrow. So basically we have discussed the then what is the system, right? So this is my system actually, and this is my imaginary boundary which basically separate the system to the surrounding, right? And the system plus surrounding is my universe, right? This is the thing. System, what is the system? The particular boundary, the particular region which is our under observation, that is called the system, okay? 3 types of the system we discussed. First is my closed system, right? Second is my open system, and third is my isolated system, guys. Closed system, what is the closed system? Heat and work both crosses the system boundaries, and there is mass transfer, there is heat transfer. I think only heat transfer is there, no mass transfer in the closed system. That's why it is called non-flow system, okay? What is my open system? Heat crosses the boundary, work crosses the boundary. There is a mass transfer, yes, there is a mass transfer. There is a heat transfer, yes, there is a heat transfer. If there is a mass transfer, then you can say my open system is also called flow system. Third one is my isolated system. It means neither heat nor work passes through the system boundaries. System boundaries are so rigid that they not allowed to pass through it. Is there any mass transfer? No, there is no mass transfer. Is there any heat transfer? No, there is no heat transfer. So these are the basically 3 types of the system, okay? So we should know about these, because there are some things which are valid only for the closed system, okay? So we should know about the closed system, open system, isolated system. Hanji. So I hope guys that you joined the class. So मोहम्मद ने क्लास ज्वाइन कर ली है, बाकी जो भी हैं जो भी स्टूडेंट्स हैं, प्लीज लेट मी नो थ्रू द मैसेज दैट यू आर वाचिंग मी लाइव, ओके? सो लेट्स स्टार्ट आवर लेक्चर नाउ. टुडे वी बेसिकली डिस्कस्ड अ थिंग दैट इज माइक्रोस्कोपिक व्यू एंड मैक्रोस्कोपिक व्यू, ओके? So guys, let's suppose this is my you can say gas and cylinder, right? Or you can say that these are the gas molecules which is enclosed in a confined space, Okay, so these are my gas molecules, guys. Okay, and this is enclosed in a vessel, you can say. If I observe the things like velocity, energy, or position, or anything, if I'm observe for single molecules, means if my study is limited to the molecules, this view is called microscopic view. This is called the microscopic view, right? It means that we are studying about the gas molecules. We are not studying the gas. No, we are studying the gas molecules. What is the behavior of a particular gas molecule? What is the velocity of a particular gas molecule? What is the energy? What is the position, like that? So this study is under the microscopic view. What is the macroscopic view? When we talk about the whole gas, when we talk about that what is the pressure of this whole system, right? What is the temperature of this whole system? What is the volume of this whole gas? If we study in the perspective of the whole gas, then that view is called macroscopic view, right? And its name, as its name suggested, that we can figure it out that what is the meaning of microscopic and what is the meaning of macroscopic. I hope that this is clear to you guys. Yes, is it clear to you? Is it clear to you? Okay, so if whole gas, macroscopic. If we will study the you can say the one gas molecules type study, then that is called microscopic view. Okay, now guys, based on the dependency on the mass, thermodynamic properties are categorized in the two way. There are two types of the property. One is my intensive property, another is my extensive property. Okay, yeah, yes, I can repeat again. See, very simple. Let's suppose we have a gas, we have any gas, like we have any gas like which is enclosed in a vessel. How the gas formation is there? You can say that there are a lot of gas molecules combined with each other, means collective gas molecules. We can say, okay, this is my gas. If I'm interested to calculate the velocity associated with the single molecule, if I'm interested to calculate the energy associated with the single molecule, like the kinetic energy of a single molecule, okay, what is the particular position of a gas molecule, this kind of studies under the microscopic view, right? So if we are studying a study of the single molecule, then it is my microscopic study. It is the microscopic view. If I'm interested about the properties of a whole gas, right? So in this picture, as you can see, that there is no any representation of the molecules. It means that we are interested to study the whole gas, not a single molecule, not a behavior of a single molecule. We are here to study the whole gas. Okay, like that we are here. I want to calculate the pressure of this exerted by the single molecule, then I will see the momentum transfer by the single molecule. This is the microscopic view. Now I'm calculating, I'm interested to calculate the pressure here. So I'm calculating the average pressure applied by the whole molecules, the complete molecules, or you can say the pressure applied by the gas. Okay, yes, Mohammed, is it clear to you now? So here, this is my gas, guys. These are the molecules. In the microscopic view, I'm interested, or you can say my study is specific to the single molecule study. Macroscopic view, I'm interested to calculate or you can say my study is basically specific to the whole gas, not a single molecule related study. Okay, done? Yes, Mohammed, please let me know if you asked any doubt, and if it is clear, then please let me know, है ना? बताओ मुझे कि that आपको clear है. so that it is easy for me to move forward. Okay, okay. Now please note down the next heading, thermodynamic properties. Please note down the thermodynamic properties. So guys, there are number of properties like pressure, okay, temperature, density, melting point, boiling point, surface tension, mass, volume, internal energy, and all that. All these are, whatever you see these 16 examples, all these examples are called thermodynamic property. Okay. So first of all, there should be a question that what is the meaning of property? What is the meaning of thermodynamic property? The definition of the thermodynamic property is, or you can say the properties is, what is the meaning of properties? It is basically descriptive. It is basically descriptive characteristics of system. Okay, so definition of the thermodynamic properties, descriptive characteristics of the system. Okay, now these properties are basically categorized in two ways. One is my intensive property and another is my extensive property. So this categorization of the property is basically based on the mass. What is the basis of this categorization? Mass, or you can say size of the matter. So the categorization of the thermodynamic property is based on the mass or size of the matter. Based on this funda, we have two kind of properties, intensive and the extensive. So what is the intensive property? Intensive properties are those properties which are independent of the mass of the system. Okay, so the basic definition is the intensive properties are those properties which are independent of the mass of the system. And what is the definition of the extensive property? Those properties which are depend on the mass of the system. Is it clear to you? So intensive properties are those properties which are independent on the mass of the system, or you can say size of the system. Size of the system, right? Or you can say the content present in the system, right? Whatever you want, you can write it. Depends on the mass of the system or size of the system. Okay. Now, so there are high chance that you forget that intensive property is dependent or independent. Extensive property is dependent or independent. So this is I'm giving you a very simple, you can say the funda to remember this. See, intensive, this in means it is independent. So this in word you can match. This in word you can match, guys. So intensive matlab it is independent on the mass, right? And extensive is parallel, it is opposite of that, means it is dependent upon the mass of the system. There are some examples of the intensive property: pressure, temperature, density, concentration, melting point, boiling point, surface tension, viscosity, and all that, right? And what is the extensive property? Mass, volume, internal energy, heat capacity, enthalpy, entropy, Helmholtz energy, Gibbs free energy. So if you will see the whole thermodynamics, whether it is of your classical thermodynamics or whether it is of your solution thermodynamics, we are, you can say that our maximum study will be related to the properties. We are basically going through the properties of the system, right? Like we will basically study the internal energy. What is the internal energy? What is the heat capacity? What is the enthalpy, entropy, Helmholtz, Gibbs free, these two energies are more discussed more in the solution thermodynamics. Okay, so now we will take the important properties and we will discuss further it, that what is this properties and all that, what is a unit and how this property is useful for us. So first of all, I will take the example of intensive property, guys. Okay, first of all, I will take the example of intensive property. Please note down intensive property. Please note down intensive properties. So as I already told you the definition, that the intensive properties are those property of the system which do not depend upon the amount or mass or size of the substance present. That is called intensive property. Now we will discuss some properties like pressure, temperature, density, volume, like that. So we will take some examples of the intensive and extensive both properties. Okay. My first example is pressure. So there are high chances of creating a 1 mark question from this, right? You can if you go through the PYQs of PSU's examination or GATE examination, you will find a 1 mark question out what kind of question you can get, that these are the examples, what are the intensive property and what are the extensive property, like that. So first example is pressure. So we are saying that pressure is my intensive property, means it is independent on the mass of the system. So very simple example. See, if you have some examples and you have to choose that which property is intensive or extensive. A very simple, you can say, thought for this is just do one thing, just cut that system in 2 equal halves and think about it. That this property is going to change or not. I am giving you a simple example related to the pressure. You are sitting in a room, and if I'm asking to you that what is the pressure inside the room, you will say, sir, atmospheric pressure, 1 atm pressure is there. Okay, now again I'm saying just do one thing, that cut this part, you can say, or install a partition in between your room and make it 2 equal parts. Okay, so we install a partition in between the room. Now the room is divided into 2 equal halves. Now I'm saying that your friend is sitting in a first half and you are sitting in a second half. Are you going to experience a different pressure? You will say, no, sir. We both experiences the atmospheric pressure. So it means that you cut down the, you can say you reduce the size, or you can say you reduce the mass, but pressure will remain same. So pressure is independent on the mass. It means it is the intensive property. I hope that this is clear to you, right? Whatever we talk about, we are talking about at the equilibrium. है? Because it may be possible that in our first half, in the portion where you are sitting, there is you can say no change, but it may be possible that in the other section somebody is sitting there also with a cylinder having some gas. Is it clear to you? Or any thing which can increase the pressure or decrease the pressure. It may be possible that the exhaust fan is there. Anything means that can, you can say, change the pressure, right? So we are talking about at the condition of equilibrium, guys. So pressure inside the gas cylinder does not depend on how much gas volume you consider. So pressure is basically the intensive property. I hope that you got my point, what I'm trying to say. Is it clear to you? Like if I'm saying what is the, see, can you tell me the density of the mercury? Roughly it is 13.6 times of the water. Okay, you are graduated students also, or it may be possible that you are third year guys, 4th year, but still these small terminologies I can expect that you know what is the density, what is the mass, like that. These data, I think there's a very general data, we should know about that. So density of the mercury is roughly 13.6 times of the water. And be specifically, if I'm giving the data that be specific, that is 13.5951 into 10 raised to power 3 kg per meter cube. This is the exact value of the density of the mercury. Okay, what is the gravitational acceleration value? It is my 9.80665 meter per second square. Okay, is it clear to you? Now here I'm trying to calculate the atmospheric pressure. Now here I'm trying to calculate the atmospheric pressure, guys. Okay, is it clear to you? See, so let's suppose that I want to calculate the pressure applied by the mercury, let's suppose. Okay, is it clear to you? So what is the formula for the pressure? Pressure formula is equal to rho GH. Let's suppose this is the formula. This is the formula. Okay, so Mohammed, can you tell me that how we can calculate the atmospheric pressure, or what is the meaning of atmospheric pressure? Can you tell me? Can you tell me what is the meaning of atmospheric pressure? How we calculate this pressure? Please let me know if you have the information about it. Anybody? Anybody can give the answer. Doesn't matter that on which platform you are watching me. Please let me know what is the atmospheric pressure and how we can calculate it. For sure, in the fluid mechanics we will discuss about it. Okay, in fluid mechanics for sure we will discuss about it, but if you have the knowledge about it, please let me know. Yes, Mohammed, any idea? There's no problem if you don't have any idea, just let me know. See, interaction is very important, guys. Okay, if I'm not able to figure out the, okay, don't worry, no worry, there's no issue. So guys, atmospheric pressure is calculated by the barometer, and here barometer is nothing but it's something like that at the mean sea level, this is the mercury field, and there is a mercury field here, and this is open to atmosphere, right? This is open to atmosphere. If this, you can say, capillary is dipped into this mercury, then the mercury basically rises in this capillary, right? Is it clear to you? At particular level it is stopped to rise. Okay, this level, this part is basically open to atmosphere. It means that it is at the atmospheric pressure. So here the pressure here and the here pressure is the same, right? At the horizontal level we will discuss in the fluid mechanics, but I'm giving a roughly idea that at the horizontal level the pressure will be same. It means that pressure here and the pressure here is same. So I'm saying that pressure here and pressure here is same. What is the pressure here? P atmospheric pressure. And what is the pressure here at this level? This is the pressure basically exerted by this column of the mercury. Okay, what is the height of this column? The height of this column, if I'm saying in the meter, then it is my 0.76 meter. This is the height of the mercury actually. So formula for the pressure to calculate from the vertical height is the rho GH. So if I calculate the pressure here, if I calculate the pressure here, see here pressure is due to the 0.6 meter column of the mercury. If I put all these value in this formula, then I am able to calculate the pressure at this point, right? Okay, so very simple, rho of the Hg, because this is the column of the Hg, so we should consider the rho of the Hg. What is the rho of the Hg? It is 13.5951 into 10 raised to power 3, and it is kg per meter cube. Multiply by G. G, this is the value of the G. It is my 9.80665 meter per second square. Multiply by the H. What is the height? This height is basically 0.76 meter, right? Or it may be possible that you remember this, that 1 atmospheric pressure is 760 mm of Hg, like that, right? If I convert it into the meter, then it is 1.76. So guys, if I calculate this, if I multiply all these things, then I'm getting pressure is equal to 101,325.01 Newton per meter square. I just multiply all these data, and I'm getting P is equal to 101,325.05. This is the pressure here, and we know that the pressure here and here is same. So it means I can say that this value is of the atmospheric pressure. Is it clear to you? So what is the value of the atmospheric pressure here? Just give me a second. I insert a slide here. Chalo, next में कर देंगे हम. Just give me a second. Yeah. So pressure value, which is my atmospheric pressure, which is 101,325.01, and we neglect basically 0.01, so roughly I can say 101,325 Newton per meter square. This is my atmospheric pressure, guys. This is my atmospheric pressure, which is we call that, okay, we are experiencing atmospheric pressure. This is the value actually. This is the value actually, right? So this is my standard atmospheric pressure. The calculation of the atmospheric pressure is basically at the mean sea level. Okay, is it at the mean sea level? If I talk about the units, then see, if I talk about the units of the pressure, then guys, Newton per meter square is basically called Pascal. What is this called? Pascal. Is it clear to you? Sir, can you tell me that how did you find the height of the meter? Height of the meter. Meter height, I think you are asking about this height. Height of the mercury column, hai na? You are asking about this height of the meter column. Yes, I can tell you. Just hold on. Okay. Just I'm explaining the units. Okay. Just focus on the units, and after that I will come to your doubt. Newton per meter square is called the Pascal, guys. Okay, so I can say 1 Newton per meter square is called 1 Pascal. There is another unit that is called bar. Another unit that is called bar. So 1 bar is basically 10 raised to power 5 Pascal. Okay, 1 bar is equal to 10 raised to power 5 Pascal. So to convert bar into Pascal, you have to multiply by 10 raised to power 5, or if you are exchanging from Pascal to bar, if you are converting the unit from Pascal to bar, then you have to multiply with the 10 raised to power minus 5. These are the some units. Okay, is it clear to you? Standard another units of the atmospheric pressure is 1 atm also. 1 atm also, right? Is it clear to you? This is the basically standard value of the atmospheric pressure, 1 atm. These are some units of the pressure: Pascal, Newton per meter square, bar, and these are the relation between the Pascal and bar, like that. Okay. Now let's come back to your doubt, Muhammad. So Muhammad, actually all these values which I'm giving you, all these values are experimental value. Okay, the barometer, Torricelli, a scientist is there which basically did this experiment, and he finds that at the mean sea level, when this capillary is dipped into the mercury, then it basically rises up to the height of 0.76 meter. Okay, this is the experimental value. Also, if you will take the water, like this is the mercury, if you will take the water into it, then do you know that what is the height? The height rises 10.34 meter. This is the experiment on the water. Right? Is it clear to you? So if I'm asking why the mercury applying the same pressure with very less height as compared to the water, if I say that only 0.76 meter height exerting the same pressure as the water exerting with the height 10.34 meter. Why? Why? Can anybody tell me? Can anybody give me the answer? Yes, because of the density. Yeah, because the mercury is denser as compared to the water, right? And roughly it is 13.6 times of the denser as compared to the water. It is 13.6 times of the heavier as compared to the water. Okay, so Muhammad, yeah, so this is the experimental value. Okay, that's why I directly write that 0.76 meter. Okay, I hope that you got my point. Yes. Okay, now so this is the pressure, and which is intensive property. This is the value of the atmospheric pressure. This is the unit of the pressure. One important part of the pressure is C. So basically we have the atmospheric pressure. We have an atmospheric pressure, guys. So let's suppose this is my atmospheric pressure line. This is my atmospheric pressure line. Any pressure may be greater than the atmospheric pressure. Any pressure may be lower than the atmospheric pressure. Is it clear to you? Is it clear to you? Yes or no? Okay. So the pressure which is above the atmospheric pressure, that is called gauge pressure. Right? This is called positive gauge pressure. And if the pressure is lower than the atmospheric pressure, then it is called negative gauge. I hope that this is clear to you. Okay. Now, one pressure is there that is called absolute zero. One pressure is there which is called absolute zero. Okay, so let's suppose this is the line of the zero pressure. So this is my atmospheric pressure line. Above the atmospheric pressure, I will call it as a positive gauge pressure. Below the atmospheric pressure, it is my negative gauge, or we use the term vacuum. Okay, we call it as a vacuum. So what is my absolute pressure? Absolute pressure is my atmospheric pressure plus minus gauge pressure. Is it clear to you? Is it clear to you? So absolute pressure is basically calculated from this baseline. Right? Is it clear to you? So this is my atmospheric pressure. So we are measuring the pressure from this line. So up to this is my atmospheric pressure. Okay, let's suppose I want to calculate the pressure at this point. Which pressure? Absolute pressure. Then what is my baseline? This is my baseline. So up to this is my atmospheric pressure, and above this, whatever this value, this is my gauge pressure. This is my plus gauge pressure, right? So what is this pressure? Atmospheric pressure plus gauge pressure. Okay, if I want to calculate the pressure at this point, then what is the value? First of all, this is my atmospheric pressure. Here we are here now. From here to here we are here. Atmospheric pressure, and in this atmospheric pressure minus this gauge pressure. So we are here. Okay, this is my absolute pressure at this point. I hope that this is clear to you. So this is the formula. Absolute pressure is equal to atmospheric pressure plus minus gauge pressure, and this is how we measure the pressure. So our starting baseline is the 0 atm, you can say. Okay, means there is a zero pressure, zero absolute pressure. So from the 0th line we basically measure any pressure. Okay, so in the question you should be very clear about it, that what kind of pressure question is asking about. I'm giving you an example about it. Okay, I'm giving an example about it. See, let's suppose you have a cylinder. Okay, let's suppose you have a cylinder. And there is a pressure meter here. There's a pressure meter here. Okay, in this pressure meter we can see the reading of the pressure. Okay, so let's suppose this meter only shows the gauge pressure, let's suppose. Okay, is it clear to you? Okay, chaliye, not gauge. Let's suppose this meter measuring the absolute pressure. So let's suppose this is at the Delhi, and we calculate the reading of the absolute pressure, that what is the reading in this meter, and we pick this cylinder, and we basically place this cylinder at Srinagar, let's suppose, at Ladakh, मान लीजिए. Okay, so tell me guys, that cylinder is same, amount of the gas is same, everything is same. One location is Delhi, another location is Ladakh. Tell me one thing, the absolute pressure reading is same for both the cases or not? This meter is showing the same reading or not? Please let me know. We are changing only the location. We are not changing the amount of the gas, temperature of the gas, anything. Okay? We just changing the location of the gas only. Ladakh pressure is less than Delhi. Okay. Why? Why it is so? Because of the latitude, I think. Okay. Now I'm giving you a different scenario. Now this is not absolute meter. This is my, let's suppose this is my gauge meter. Let's suppose this is my gauge meter. Now what is the case? Reading will be same or different? Reading will be same or different? Reading will be different or same? Please tell me, reading will be same or different? Okay. So please pay attention. Okay. See, this is my cylinder. First of all, you need to understand what is the meaning of atmospheric pressure and what is the meaning of gauge pressure. Atmospheric pressure is basically related to the atmosphere. What is the atmosphere? What is the atmosphere of the system? Okay, is it clear to you? And while we calculating the atmosphere, we are having the formula rho gh, right? In general, in the atmospheric pressure, how much the air column exerting a pressure on a particular body, and this is calculated at the mean sea level. It is calculated at the mean sea level. Level means this h height. From mean sea level, what is the height of this h, right? Is it clear to you? So yeah, this is so obvious that the height of the Delhi is less as compared to the Ladakh. Is it clear to you? So here this is my h1 and here it is my h2. So this h1 and h2 is different. It means that the atmospheric pressure at the Ladakh is different as compared to Delhi, right? Atmospheric pressure is different in both the cases. Is it clear to you? Now if we asking about the absolute pressure, in the absolute pressure there is a term of atmospheric pressure and there is a term of gauge pressure. So atmospheric pressure is different in both the cases. What about the gauge pressure? Gauge pressure means the actual pressure exerted by the gas molecules in the cylinder. There is a gas in the cylinder. Gauge means the actual pressure exerted by the gas molecules. This is my gauge pressure. Is it clear to you? So gauge pressure is independent on the atmospheric pressure. There is, you can say, no any relation of the gauge pressure of the atmospheric. You change the atmosphere, take the same system anywhere, gauge pressure will be same. If you are installing a gauge meter here and you are roaming here and there, irrespective of the location, you will find the same reading, because until unless you change the gas, your pressure will be same, guys. If your gas is same, there is no leakage, there is, you can say, no any change, then the gauge meter will show the same reading, right? So this is about the gauge. If I'm asking about the atmospheric, then if you change the location, if you change the atmosphere, then the atmospheric pressure will be different here. Okay, so if somebody is asking in the interview that gauge pressure will different, we will say no. If gas is same, there is no leakage, then gauge meter will show the same reading at both the location, right? Okay, what about the absolute pressure? So we are saying that yeah, gauge pressure amount is same, but atmospheric pressure amount is changing, so absolute amount is also changing, because absolute pressure is basically you can say in the absolute calculation we consider atmospheric as well as the gauge, right? So absolute pressure is changing due to the atmospheric wala part. Mohammed, clear? Is it clear to you? Am I clear with this or not? Please let me know. Please let me know that I'm clear with this or not. Please let me know. Okay. So this is your atmospheric pressure, or you can say this is your zero gauge. This line is basically your zero gauge. Here gauge pressure is 0. Okay, is it clear to you? Okay, so this is the whole discussion of the pressure. Okay, now we'll talk about the volume. So what do you think, guys? Volume is a pressure, volume is a mass dependent or independent? So it is so obvious. Let's suppose we have a room, again the same example. Okay, and it's you can say volume is let's suppose 6 meter cube. Okay, 6 meter cube is the volume, let's suppose. If I cut that room, if I divide that room in the two equal halves or in any fraction, then it is so obvious that volume will be different. Yes or no? So for sure, volume is a mass dependent quantity, or you can say size dependent quantity. So volume is my extensive property, not the intensive property. Okay, so volume, if I will say the definition of the volume, then it is the 3D space occupied by the body. Occupied by the body. Is it clear to you? If I'll talk about the unit, guys, then there are some basic units like meter cube. Okay, and I can say 1 meter cube is equal to the 10 raised to power 3 liter. Okay, again I can say 1 meter cube is equal to 10 raised to power 6 cc. Cc means cubic centimeter cube, right? This is the meaning. Okay, is it clear to you? Is it clear to you, right? Okay, in this in the continuation of the volume, there I'm explaining a part that is called specific properties. There is a specific properties. So in the engineering, specific properties means properties per unit mass. Specific properties means any property divided by mass. If you want to define any property with respect to the mass, then that property is called specific property. So specific property means divide by mass. Very simple, divide by mass. Is it clear to you? Okay. So if I'm saying volume, this is my volume. If I'm saying define specific volume, specific volume means that I want to explain, or you can say I want to basically interested to calculate volume per unit mass, guys. Per unit mass. Is it clear to you? What is it? It is my 1 divided by rho, means density. Is it clear to you? Density is what? Density. What do you think? Density is the intensive property or extensive property? What is the density? Density is the intensive property or extensive property? If I'm saying, then I can say this, what? That density is equal to mass upon volume. So in the formula there is a mass. So can we say that this is the mass dependent property? Please let me know. Please let me know this. Can I say this? Can I say this? Yes or no? Please let me know. Yes, Mohammed, what do you think? Density is the intensive or extensive? So density is your intensive or extensive? Intensive property. Yes, it is intensive property. It is not extensive property. If you see the formula, you will see the mass and you can get confused that okay, there's a mass in the formula, so this is the mass dependent quantity. No, this is the no mass dependent quantity, right? So again, क्या करना है हमें? How we can understand this? How we can figure it out? Like, see, there is a 1 glass water and same water. I'm talking about same water. Let's suppose we have a RO. We basically take out 1 glass water from that RO and we take 2 liters bottle water from the RO. What is the density of that water? The density of the water will be the same. Let's suppose what is the density of the water? 1000 kg per meter cube. So this 1 glass water, 1 drop of water, 1000 meter cube water, whatever is the volume, the density will be same. Is it clear to you? So density is the mass independent quantity. So it is the independent, so it is intensive quantity. Is it clear to you? Is it clear to you? That's why this is my intensive property. So I can say that specific volume is my extensive property, but specific volume is my intensive property. Yes or no? Is it clear to you? So I can make a statement here. I can make a statement here that any extensive property divided by mass becomes intensive property. Is it clear to you? Or you can say any specific, or also you can make this statement. I don't have the space further, so I'm writing here that I can say that all the specific properties are intensive property. That's why I basically couldn't take the density separately, because यहीं पे हम इसको समझ सकते हैं. We can understand this here also, right? Is it clear to you? So all the specific properties are the intensive property, guys. Whether it is specific volume, whether it is specific anything. Right? Is it clear to you? So you should remember all these examples. What is the pressure, temperature, density, concentration, melting point, boiling point, surface tension, viscosity? These are the examples of the intensive property. What are the examples of extensive property? Mass, volume, internal energy, heat capacity, enthalpy, entropy, Helmholtz energy, Gibbs energy, like that. So if you stuck anywhere in choosing the properties, then very simple funda, you'll follow very simple funda that just choose one property and just try to divide that property in the two halves and try to think about it that yeah, now this particular sections has the same property as previous or not. Correct? Some of these properties we have discussed, like we have discussed the pressure, we have discussed the volume, we have discussed the density, like further we have discussed the temperature. My next property is the temperature discussion, where we will study about the temperature, what is the temperature, how we measure the temperature, what are the different scales of the temperature, like that. Okay, right? So this is it from my side for the today's class, guys. Okay, and just revise this part, and this is you can say very basic informations I'm giving you in the initial lectures. So there should not be a very burden, because we have a good, or you can say enough of time. Just revise all the things very, you can say, minutely. Okay, just revise all the informations, right? And only then you can understand the further things, because the further things are, you can say that all the further things are related to all these things which we are studying here. Okay, so in today's class, if you have any doubt, you can ask. You can ask about anything. You can ask about any property. You can ask about any you can say intensive, extensive example or anything. Please tell me if you have any doubt about it. Yeah, one more thing, if you, some of you is basically, working professionals, so please, whenever you watch the lecture, please let me know through the message. After watching the lecture, please drop a message in the Telegram group, so that I assured that okay, आप लोगों ने lecture देख लिया, ठीक है? What is the relationship of the microscopic and macroscopic to the thermodynamic properties? So Mohammed, whatever we study these properties like pressure, volume, temperature and all that, we are studying these properties for the whole system. We are not doing the microscopic study here. We are doing the macroscopic study, right? Is it clear to you? In the kinetic theory of gases, we take the microscopic approach, but in the thermodynamics, most of the part will be your macroscopic study. So whatever we talk about the pressure, it means we are talking about the pressure of the whole gas, not for a single molecule. If I'm talking about the volume property, it means I'm talking about the whole gas volume, not volume occupied by the single molecule. If I'm talking about the temperature, it means the temperature of the system, temperature of the whole gas, not the temperature of the single molecule or like that. Okay, so in thermodynamics, we basically study the macroscopic view, not microscopic view. Is it clear to you? The doubt is clear, Mohammed? Okay. So, okay then, I hope that you understood all the things, but still just revise all these things, and let's meet tomorrow. Okay, now in the next class we will discuss the temperature. That will be the, you can say, the important topic, and GATE is basically can ask the question based on the temperature and all that. Okay, so we will discuss it tomorrow. Okay, so thank you so much for watching this, and I hope you enjoyed the class. And okay then, if you have any problem, yeah, yes, please ask. Please ask, Mohammed. Last lecture we discussed about the systems. Can we relate it to this lecture? I did not understand what I'm trying to say. Yes, system. Yeah, obviously. See, we are discussing the properties now. Okay, so let's suppose I'm talking about the pressure. Okay, let's suppose I'm talking about the pressure. Let's suppose I have this cylinder. right? And a gas is filled into this cylinder. Okay, so I'm interested to calculate the pressure of this gas. Okay, pressure of this gas exited on the walls of your cylinder, right? Is it clear to you? So what is our system? Our system is this cylinder plus gas. This is my system, guys. Around this, except this, whatever is this is my surrounding. So whatever we calculate, or you can say that whatever we calculate the pressure, that pressure is basically of our gas, of our this gas exerted on the walls of the cylinder. So what is my system? This is my system only. Yes or no? This is my system only. Other than this, whatever it is my surrounding. Okay, Muhammad? Is it clear to you? So this is, you can say now it's the starting. We are only discussing the definition of the properties, units of the properties, formula of the properties, right? Further, we have to apply these concepts to our specific systems. Where we defining our systems, we will calculate the pressure of that particular system, right? We are choosing our system onto which we want to do the study, which we want to get the information about the properties. Okay, so these are only the terminologies we are basically discussing. These are the small things actually. Okay, so you will see that, okay, this is my system. Here we are going to do the study on that particular system like that. Okay, yeah, but till this lecture, I basically explained your doubt that what is the system and all that. Okay, then thank you so much. Let's meet in the next class. Bye bye and take care, guys.